Hi everyone, I'm Mathieu and super excited to be here with you and my coworker Sayan to speak at the Conf42. So today we're going to talk about securing and hardening your container host. Thanks again for the invitation, Conf42, and yeah, let's begin. It all starts with the command. So let's suppose you want to deploy a cluster into your favorite cloud provider. Let's suppose it's Google Cloud Platform. You're going to write this command, gcloud container clusters create. And it's going to create a cluster with 2 or 3 nodes, depending on the flag you provided. And we can ask ourselves, but what's behind this cluster? I mean, this cluster relies on something, and what is it? So what is it? It's a container OS. Container OS are not so different from regular Linux operating system. They're just designed to run container workloads. By container workloads, we can talk about simple Docker containers or bigger infrastructure like Kubernetes cluster. They are also designed to have a minimal footprint in order to be seamless as possible and to focus on the workloads itself and not on the underlying OS. We can have a look to the various container OS in the ecosystem. So most of them are provided by cloud providers. So we can talk about BottleRocket from AWS, but also Container Optimized OS from Google. But we also have some more friendly open source solution like Carefree OS or Flatcar. So this leads to introduce myself and my coworker. We both work in the Flatcar team maintainers, and I mainly work on testing the operating system before releasing it. And I will let Sayan introduce itself.
Thank you, Matthew. So, hi, I'm Sayan. I work with Microsoft, working on the Flatcar Container Linux projects as one of its core team members. And it's been like 2 years I've been working on these projects, and I primarily look around with the release work, doing the release planning, and also the package maintenance in the Flatcar ecosystem. Okay, so to tell you a short story here, you probably have heard of Chrome OS or the Chromium OS. So Chromium OS was built on Gentoo, and the Google folks built a mechanism of the update mechanism, and also implemented the immutable partition system. And then CoreOS came into the picture, and they built Container Linux, and it was built out for Chromium OS. And Chromium OS was the Container Linux was actually like a very good container focused operating system, and was widely known in the community. But when CoreOS acquired Red Hat, Kinfolk, the company that started out Flatcar, actually they forked out the project out of Container Linux and started developing Flatcar Container Linux project. Over to you, Matthew.
Oh, sorry, I was muted. Thanks,
No worries.
Sayan, for this short bit of history. So now we have a set of this talk. So let's talk about the main characters, Alice and Bob. Alice and Bob are tasked to do one thing. They need to rework a bit the infrastructure in order to provide a secure environment, especially from a container OS point of view. So they ask themselves what can be do in order to secure the container OS which support their cluster. So we can talk about a couple of technologies, and they're just here to give you some ideas of what's possible in terms of security into container OS. Let's first talk about audit. So audit is a Linux framework. Basically, it's going to fetch data bring by the kernel in order to display them to the user as a log. So using audit, you'll be able to have a good overview of what's going on into your system, and you won't be blind anymore. Also, audit can be used with rules, so you will define what you want to see and what you don't want to see. So these rules are pretty simple. You just have a bunch of flags, and you need to dig into the manual page to see which flag can be used with which other flags, and like so you'll be able to filter input and output of audits. So, for example, if I want to audit everything which is related to Docker, I can just add a simple rule. So, with this example, we can see that I run a Docker image command just to list my current images on my system. If I check the journal, I won't see anything because I don't log anything. So now I'm going to add a rule just to say that everything is going on with user bin docker path, and which is an execute command. I want to log them to the user. So once I have my audit rules, I can just do my command as usual, Docker images or whatever other else Docker recommends, and I will see in my journal that some things happen and some things happen in matter of Docker. So like so, I bring some visibility to my system. So yeah, this is nice. I'm not blind anymore. I can continue to walk with some visibility into my system. But now we can ask ourselves, okay, we have a framework to print stuff, to print logs. So what can we do with this log? So Audit is a framework, so we can easily plug other tools to it. Let's talk about SELinux then. SELinux is initially developed by Red Hat, and it has been included and open source in the kernel since the beginning of the 21st century. And it provides some granular control from a system administrator point of view. So SELinux is defined in three main types. So you have the activate tab. So basically, SELinux won't be activated on your system. You also have the permissive mode. In this mode, SELinux will just log everything you try to do against the policy you defined into your system. And finally, the enforcing mode is going to block any command who try to do something which are not authorized by the policy of the system. So most of the time when you heard about SELinux is when something does not work because it has been blocked by the enforcing mode of SELinux. So too lazy, didn't read, try to avoid to deactivate SELinux. First, you can deactivate it temporarily to confirm that your issue is caused by the enforcing mode of SELinux. Then you can submit an issue on the repository of your distro, of your Linux distro, in order for the maintainer to patch the policy shipped by the system. So it's quite complicated as a distro maintainer to find the right amount between being too restrictive and too less secure into the policies you shipped into the OS. So this is an example of SELinux working in enforcing mode of the system. I'm just going to run a Docker command which is going to share a volume between the container and the host, and this volume is a simple file, the etc machine ID. So let's suppose I want to override this unique machine ID to a new ID. I won't be able to do it because SELinux is in enforce mode, and this write action is not authorized by the policies as long as the label mismatch between the host and the container file system. So that's it for SELinux. So with SELinux, you can understand that it's possible to create complex policies because you can define some macro and define some allow and deny rules. But now, if I want to have a more deeper granular control into my service, what can I use? So Sayan is going to talk with you about the capabilities and how you can use them to provide more control on it.
Right. Thank you, Matthew. So yeah, so now that we know about SELinux and audit, so you can say that audit is primarily used to like know what's happening in the system or who is doing what in the system, and then you have the SELinux field, which is primarily, in short, you can say that it's an ACL kind of thing which controls the access. And now when you suppose you're tinkering around with SELinux, you are reading through the docs, you will be ending up reading somewhere around capabilities. This term has been there for some time now, but before going into more depth, I would like to point out the fact, like the talk that we are giving around hardening and securing the host. One core idea of the talk is to basically reduce the attack surface. What do I mean by reducing the attack surface, or why do we need to reduce the attack surface? The answer is basically, suppose you are running a host and the lesser number of entry points that you have for the attacker, or reduce the attack vector, you are at the end of the day getting a more robust and secure system, which given the age we are staying in, where data is kind of the new oil, and all the processes are very heavily data driven, so and user driven. So in that scenario, the data protection would be there. Now, most of the Flatcar or the any other container OS that we displayed in the beginning already focuses a lot on this aspect. But before, but with this introduction of the tools that we are giving, like audit, SELinux, and then ones that I'll be showing, the idea is that your host will, at the end of the day, get more secured. Now, coming back to capabilities, you can say that, as mentioned in the slide, that you can say capabilities is a way to provide a very fine-grained control of the super user privileges or the root privileges. Now, you may ask how. So let's see that in the next slide. So as you can see here that we have when capabilities implementation was done in initial implementation, I can say here. So the traditional implementation was primarily can be divided. The access controls stuff can be divided into like two categories. One is the privileged process you have, and then the other one is the unprivileged process. By privileged process, you could make or you could understand that is primarily run by root, and you really don't need all those. It can actually bypass all the kernel permission checks. But then you have the unprivileged process, which are run by normal users, which really have to go through this all permission checking. And if you don't have the required permission, you will end up with an error. So these unprivileged processes are actually subjected to this whole permission checking, like based on the effective UID or the GID. And to say here, like it's actually limited. It's really like a binary system where you have a 0 or 1. Next slide, please. So to work around the system, Linux capabilities was introduced. It has been there for around some time now. It was introduced in kernel 2.2. And the idea here was to actually break up the super user or the root privileges into very smaller, very specific focus privileges. And it would give you that extra freedom to independently turn on or turn off that particular capability for a particular process. And this is a very good way to reduce the risk by a huge amount, because if a process has like 20 capabilities and you reduce it down to only that 1 or 2 capability, you are actually reducing to a great extent that attack surface area. Now, if suppose you have a process running and it is compromised, and given the it has the appropriate capability, in that scenario it's highly possible that the attacker might not get the it cannot fully compromise the host or cannot take control of the host totally. It's possible, it's highly possible that they cannot do that. Now to put this into a better picture here, suppose you have a process running as a normal user. Now it's usually like you are it's not basically it's non-privileged here, and at some point of time you usually need to do a privilege activity. Suppose you need to open a say network socket. So what do you do there? So in that scenario, you usually suppose you require root permission, you just go into root, but instead of that you can take control using capabilities. Moving to next slide. So capability set, there are these definition in capabilities. They are called sets, and as I told, it's primarily around process. So it's a capabilities are per thread attributes. So now you can see here I mentioned a couple of sets here. So there are permitted sets, you have inheritable sets, you have the effective sets, bounding sets, and ambient sets. Now what are these? So the primary ones I would say are around effective and permitted. So effective set is where the capabilities will be verified for each privilege action that kernel is doing. So if a process wants to perform an action, the capability should be there in this particular effective set. And then you have the permitted set, where basically these are those capabilities that can be introduced into effective and inheritable set. Then you have the inherited capabilities, which are like the capabilities that this particular it lists the capabilities which can be inherited from a parent process. New capabilities was introduced, which was the ambient capability, and this capability is primarily around to preserve the capabilities across execv calls. But you need to remember that these capabilities also, if a particular capability is dropped during the process execution, they should, when if they have to be picked up again, they have to be follow the inheritable and the permitted rules that apply. And then you have the finally the bounding set, which is the like the superset, and nothing more than this can be done. So quickly showing you a small example. This is probably a process, if I recall correctly, I was doing around audit. So it if you see in the status file, you have like these all capabilities mentioned there. You have the inherent, permitted, effective, bounded, and ambient, and it has the hex code. But how do you understand more from that? So you have the cap sh command to decode that particular hex. So it's primarily shows all the capabilities there. But if you want to, like, it's a bit tedious to do this two-step, but if you want to quickly show do stuff in here, you can use the get pcaps command and the process id and get the details. And then to set a capability, use the set cap command. Moving on to the next slide, I'll show you an example. So to give you an example here, so we all use a ping program, and it is usually shipped in most of the Linux distros. And usually in most of the distros, this particular program has the setuid root. So this is because that it needs to send this raw network packets. But but this is not there for the non-privileged users. So instead of that approach, what you can do is that you can just take the capabilities into picture and use the net raw capability and not the setuid. You can drop that. So just to explain the example, we are using an Alpine image here. In the first example, we drop all the capabilities and try to ping flatcarlinux.org, but as guessed, the permission was denied. But then what we do is that we add that particular one capability, and that's how like we can do the we have the ping working back again. So these are small tweaks that you can start doing around your applications to get to build a more secure environment for your applications. Okay, so now moving on to the next slide, we have a SecComp. So SecComp stands for like secure computing. It was introduced in Linux 2.6.12, and to say simple words, it's basically a sandboxing tools to filter out system calls that happens on the system. Next slide, please. So as I mentioned before in the previous slide, that SecComp was introduced in Linux 2.6.12. So in the first iteration of SecComp, what happened was that it was like enabled by just writing one to this PID file, and there was this SecComp file in there, pretty simple and straightforward in there. But once enabled there, it would have access to 4 system call, which was read, write, exit, and sig return. But in the next iteration, the interface, the previous interface of writing was changed, and to enable you use this prctl system call. And what it did was basically it enables the seccomp, and you just need to add the pr set seccomp and along with the strict mode. To say there about the seccomp modes, there are 2 of them. One is the strict mode, and the next one I'll introduce after some time. But before that, I'll show you the example of strict mode in the next slide. So here we can see that we are opening a file in write mode and write only mode, and then we in the next line we activate the seccomp. And what after activating that, we are trying to write to the existing descriptor. But the next step that we do is doing a trying to open the file in a read-only mode. But you can see that the program after enables the strict mode, but if you run this code, you will see that it can write to the std out. It will write that first and the second output, but then once the secomp is activated, it won't be able to open the file in the read-only mode, so it would get killed. Okay, no, so now moving to the next slide. So here you can understand from the strict mode that it was a bit limited. So in the later iterations, after like staying there for 4-5 years, after that a new mode was introduced, which was a SecOp BPF mode. And in this particular mode, we usually use BPF program for doing all the packet filters, network packet filters and stuff. But then SecOp was also introduced as an extension to the previous SecOp mode. And what it did was like you could start filtering out more system calls, more generic system calls in here, and you can like not be limited to the number of system calls. And also previously in strict mode, you can just use the sick kill, like kill using sick kill, but then in the later you could actually send out multiple return values from your program. So to show you an example in the next slide, you have here like I'm trying to allow a couple of 6 calls in here. This is particularly a snippet of the main code. But to explain you like what we are doing here in the strict mode is very similar to strict mode, but what we are doing here is in strict mode, we have like read, write, open, and exit, but we are dropping the exit and introducing a new one called open. So we are open to, so you are actually free to add more system calls. Now, next slide. Okay, so one of the place where SecOp BPF was very heavily used was in Docker to provide a very protective environment for the applications. Now, the default profile gives you a very good environment for running your containers, and it drops around, I guess, 44 of the system calls. But in case if you want to change that environment and you want to open up a few syscalls or make it more restrictive, in that scenario you can actually create your own custom policy file and then pass it through the secure opt argument. And here in the example you can see I have used the security opt argument and along with the custom path. And that's wraps from my side. Over to you, Matthew.
Thanks, Sayan. That was awesome. So let me just add another details. With Flatcar, Docker comes with seccomp SELinux enabled by default in the security options. So I would like to add that this is some technologies we shown, some tools, and security can also be bring using the way you build the container OS. So this is an example with Flatcar. With Flatcar, for example, we don't ship any package manager. So with doing that, we prevent some drift between the way we ship the actual OS and the way it lives in the time. So you avoid to drift from the initial release of the OS. Also, we control the package dependencies we want to add into the image. Thanks to the Gen2 history, we can enable or disable some features using use flag on the package. This is an example with Samba, and we decided to disable the regedit in order to minimize the package size, but also, once again, to decrease the attack surface of the OS. The less you ship, the less you need to take care of. And finally, /usr is in read-only mode, so we only use the configuration we ship into the OS, so you just can be sure that there is nothing between both of them, between the way it is loaded into your program and the way we ship the configuration. So I think that's all. There is a bunch of tools, as you can see, but you can find a bunch of more of tools. So it's just the beginning, and with that you can start with your toolbox to Alice and Bob to secure and harden their infrastructure. So as we say that in the Flatcar team, that security is an incremental process like many other things. So you need to try and to test and to learn from your tests. So that's all from our side. Thanks, Sayan. Thanks, Conf42 once again for having us. So this is our social handlers. If you want to ping us or to send a message, send a question, don't hesitate. Thanks again.
Thank you.